The product of two consecutive even integers is 168. Find the integers. When we're thinking about consecutive even integers, those are even integers that come one after another, like 2 and 4, or like 8 and 10, right? You can see that this one comes right after that one. They're both even. So we're kind of skip counting. Now, we don't know where our first one starts. So we're going to call it x. And that's kind of what that 2 represents, 8 represents. We're thinking about how do we get 2 to be 4? What do we have to do to this x to make it be 4? If we added 2 to that one, we could get it to the next one. Same way with this one, we just have to add 2 to get to the next one. So that's the relationship between consecutive even integers. Some problems might even ask you that there's 3 of them. So we need to skip count again, so we would reference x. But this would be 12 at this point, so if we were getting a third one, we'd have to add 4 to get to that third one. So we may have problems come up that look like that. But for now, our first one is going to be x, and our second one is going to be x plus 2. Our problem said that this is the product of two consecutive even integers, so we're multiplying these two things together, and our answer is 168. Now we're going to go ahead and distribute this x. X times x is x squared. X times 2 is 2x. This still equals 168. We're going to subtract this 168. Subtract this 168. So we get x squared plus 2x minus 168. And now on this side, since these were opposites, or when we did the subtraction, this leaves us 0 on this side. So we're looking for something that multiplies to give us negative 168 and adds to give us 2. Well, we can consult our calculator. So we're going to put in negative 168 and see what we get. And so we're going to get 2 linear factors. This multiplies to be a negative, so we should multiply and get a negative and a positive. Not really that we should, but we're going to. Now, we should have numbers that are 2 apart. When we have the negative here, our bigger number is going to be positive since this is positive. And they're 2 apart. So let's look for something that's 2 apart. So let's get them closer to each other. And we're creeping up on it. There we go. And like I said, we want the bigger one to be positive. So our 14 is going to be positive. The 12 is going to be negative. Now when we're solving this out, these two things multiply together to give us 0. So one of these parentheses has to equal 0. That way when we multiply it, we get an answer of 0. So we're going to say x minus 12 has to equal 0, or x plus 14 has to equal 0. Well, if we continue solving this out, we'd add 12 to both sides and figure out that x equals 12. We'd subtract 14 from both sides on this one and find out that x equals negative 14. Well, we were looking for positives, so we don't want to use this one. We're going to use the 12. So we're going to plug in 12 here. That means our x equals 12, so on our second number, this equals 12, so we do 12 plus 2, and that equals 14. So that's our 2 consecutive even integers. Actually, it didn't say positive. We could have used the negative 14 as our first one, and if we added 2 to it, it would be negative 12. So you can imagine that it would work both ways. Most people just like to use the positives. The height of a triangle is 4 yards greater than the base. The area of the triangle is 70 square yards. Find the length of the base and the height of the triangle. So first thing we need to know in this problem, we are doing area of a triangle, so we need to have our formula, which is the area equals half the base times the height. And we have everything represented here. It actually said that our height is 4 more than the base. So base becomes our variable that we're using. And so our height becomes this expression. It's the base plus 4 more. So we're going to replace all our things here and here. So our area is 70. We got half. And we got the base, which is still b. And then our height is b plus 4. Now I want to get rid of this half right away. And there's two different ways of thinking about it. They both lead to the same thing. If we have a fraction in our problem, we can multiply by the denominator, get rid of that fraction, which gets rid of this. Or you could think about it like we're multiplying it times the reciprocal. That means that we're going to flip this fraction over. So when we flip it, 2's on top, 1's on bottom. Well, 2 divided by 1 is still 2, so we're multiplying this thing by 2. Well, 70 times 2 is 140. And so that cancels away here. We can go ahead and distribute this b. So b times b is b squared. And then b times 4 is 4b. I'm going to subtract this 140. Subtract the 140. And so we get 0 equals b squared plus 4b minus 140. And so if we're looking for things that multiply to give us 140 and add to give us 4, we're going to list off our factors. We want our positive number to be the bigger number because that's what our middle term's telling us. So we got a negative 1 and 140, a negative 2 and 70. 3 doesn't work. 4 does. That's negative 4 and 35. 5 works. We got 5 and 28. Yeah. Let's do 6 doesn't work. 7 does. 7 and 20. We got 8. 8 doesn't work. I think our next one is 10 and 14. And that's when we arrive at what we're looking for, because if we added those two together, we get that 4. So this is going to be b minus 10 and b plus 14. And now one of these has to equal 0. And if you noticed on our last one, we had a negative 12 here. We got an answer of 12. We had a positive 14. We got a negative 14. So we kind of see a pattern forming. So that means that our b is just going to be the opposite. Instead of being a negative 10 here, it's going to be a positive 10. You can see 10 minus 10 would equal 0. 0 times anything would give us that 0 there. And b equals negative 14. Now we can't use this negative 14 because we're dealing with measurements. If we plug this in and said our measurement from here to here is negative 14, that doesn't even make sense for a triangle, because if we take out our tape measure, we never get negatives. And so that base equals 10, and our height equals, we're plugging the 10 in here, 10 plus 4 is 14. One number is 24 more than another. Their product is negative 144. Now, this means that we're adding 24 to whatever our mystery number is. So we usually assign it as x like they did. So that means that we're adding 24 to whatever that x was, and then we're multiplying those two things. So we got x and x plus 24. Whenever we put either a number or a variable next to the parentheses, that means we're multiplying. That's what product tells us, and that answer is 144. So this is going to be the way we're setting this thing up. And now we have to solve it. Since we set it up this way, we're going to go ahead and distribute this. X times x is x squared, and then x times 24 is 24x. That equals negative 144. We can add this 144, add the 144. And so we get x squared plus 24x plus 144 equals 0. You can look it up in a calculator. one of the easiest math facts I can remember to give us 144 is 12 and 12. And 12 plus 12 gives us that 24. So this thing's going to be x plus 12 and x plus 12 equals 0. So this thing equals x equals negative 12. We would find that x equals negative 12 here. Okay. So that means that whatever our x was, this guy's going to equal 12. But our second one, which is what's represented by this parentheses, this is 24 more than that negative 12. So if we add 24 to this negative 12, well, 12 gets us back to 0, and 12 more gets us to positive 12. So negative 12 times positive 12 gives us that negative 144. An architect wants to draw a rectangle with a diagonal of 25 centimeters. The length of the rectangle is to be 10 centimeters more than twice the width. What dimensions should she make the rectangle? So we have this rectangle. She said that the diagonal is supposed to be 25 centimeters. And then it said the length is to be 10 more than twice the width. So we're using our W as our variable since that's what they compared the length to. And that's the expression we can make it. Rectangles have right triangles in all their corners, which tells us that we can use something. Cool, you should have learned when you had a right triangle, that's when you can use Pythagorean Theorem. That's a squared plus b squared equals c squared. Our a is going to be represented by that w. This is going to be represented by our b. And then our c is represented by that 25. We're going to go ahead and plug these in. We're going to say that this is w squared plus, and I got 2w plus 10 squared, and this equals 25 squared. Now I'm going to not do this the long way because I need to expand this one out, but this is just 2w plus 10, 2w plus 10. And you can do it the long way and FOIL it out and do this times this times this times this, and then this times this, and then add your two like terms together and get this. But I'm going to show you a fast way to do it. W squared still stays that. If you want to figure out what our first term is going to be, we're going to do 2w times 2w, and that gives us 4w squared. To get our middle term, we're going to do this term times this term, which gives us 20w, and then we're going to double it. So we're going to times it by 2. So 20w times 2 is 40w. And then our last term, we're going to do 10 times 10, or 10 squared, which is 100. And if we did the square of 25, that is 625. Okay, so we're going to combine like terms here. So this gives us, we're also going to subtract 625. And this process too. Okay, so w squared plus 4w squared. Well, when we don't have a number in front of our variable, it's a 1. So we're just doing 1 plus 4, which is 5w squared. Then we got 40w. And then 100 minus 625 is 525. And this equals 0. Well, now we think about what's our greatest common factor in this thing. And we should say that it is 5. So we're going to take out a 5. And that leaves us with w squared plus 8w minus 105. This 5 just kind of becomes irrelevant. We're going to have a positive and a negative on this since our product is negative. So we're looking for something that gives us product of 105. And they're 8 apart. We jumped right to it. There it is, 15 and 7. So because our 8 is positive, the 15 has to be positive, which makes our 7 be negative. Now, if we plug in a negative 15 for our w, that would make that be 0. So 0 times this would be 0. And w could be 7 here. And now we can't have a negative measurement just like we couldn't on the last one. Have to discount that one. So our width has to be 7. Now, if we're thinking about our length, we have to plug it in here. So we're doing 2, and we found w equals 7, so we plug it in there, 7, and then plus 10. Well, if we do 2 times 7, that's 14, plus 10 more is 24. Find two consecutive odd integers such that the sum of their squares is 130. Just like we did on the consecutive even integers, we're thinking about this like consecutive odd. Again, we're skip counting, so we're going 2 more than that next one. Now, we don't know it's 3 or 5 or whatever. We're trying to figure that out. But it said it's the sum of their squares. So basically, we're adding these things up, but first, we're going to square them. So we're going to square this x and add it to the square of this x plus 2. And that should equal our 130. Now we're going to expand this thing out. We got x squared. We square that one, which gives us x squared. We multiply these two together and then double it. So that gives us 4x. And then we take the square of that one, which is 4. That still equals 130. We're going to subtract this 130. And then combine these things. So we get 2x squared plus 4x. And then we get minus 126. And this equals 0 now. Now we take out a greatest common factor. We look at this and go, I can divide everything by 2. So we'll take that out. Get x squared plus 2x. And then minus 63. And so we're looking for two linear factors. The two numbers multiply to give us negative 63, and they add to give us positive 2. And you can work on that. You should be able to find that you get 9 here and 7 here. We still got our 2 out here. We're going to find that this x equals negative 9, and this x equals positive 7. So I'm just going to use the positives on this, and we're going to say x equals 7 here. And then we plug in our x right here. So 7 plus 2 equals 9. So these are our consecutive ones. Now, if you want to double check it, remember we did the sum of their squares. So we did 7 squared plus 9 squared. And that should equal 130. Well, the square of 7 is 49. And the square of 9 is 81. And if you combine those, you'll see that it does actually equal 130. So this checked out. An orchard has 616 pear trees. The number of rows exceeds the number of trees per row by 6. How many trees are there in each row? When we have rows, what it's saying is there's a tree here, there's a tree here, and there's a tree here, and this is a row. So this thing could keep on going on and on forever, right? When they're talking about the trees, they're talking about the tree in each row. Okay, and these could keep on going on forever that way. Now, if we wanted to figure out how many trees are in the orchard, we would take the number of rows that we have and multiply by how many trees are in each row. So basically, we would multiply the trees times the row, and that should give us our total number that we have. Now, if we do t times t, that gives us t squared. T times 6 is 6t. And then that gives us 616. Oh, yeah. And we could minus our 616. Minus 616. And that gives us t squared plus 6t minus 616 equals 0. And negative 616 divided by x. Right? They should be 6 apart from each other. And that's what we're looking for. And our positive was the bigger number. So that's going to be 28 here. And we'll have 22 here. That means that this is going to be positive 22 and negative 28. Now, I've never went out to an orchard and counted negative 28 trees, so we cannot use that one. They have to be positive. So the number of trees is 22, and the number of rows is 28 because we plugged in the 22 here. It's a lot of times you'll see that that does become that, but it's not on all of them. So don't just assume that that's going to be the case every time. That it's just because they gave you the negative one doesn't mean that that's always going to be what your positive is. You always have to plug in this number into your t, and then do whatever they said was being done to it. Sometimes it might ask you for the rows. Sometimes it might ask you for the trees. So when you're putting this thing in, you don't want to make that mistake and just assume that they're talking about trees. So just read how many trees are in each row, so that way you know what you're looking for. And our answer is 22. Consider two consecutive positive integers such that the square of the second integer added to 4 times the first is equal to 161. It gives you a few clues, right? So we know that when we have our first integer, we're calling it x. And our second integer, we're going to call it x plus 1. Now it said that the square of the second one, so we're going to be squaring that x plus 1. So we got two of them that fit that criteria. So we can go ahead and say, nope, it's not going to be that one. Nope, it's not going to be that one. So now we're looking between the first and the third one. And it says it's added to 4 times the first. Well, this one isn't doing 4 times the first. This is the only one that's doing that. And that should be equal to 161. So this is our answer. And now we're going to solve it out. So first we're going to expand this parentheses. So we're going to have 4x plus, and we're going to square that one, which gives us x squared. Multiply these two by each other and then double it. That gives us 2x. And then square that one, which gives us 1. This equals 161 still. So we minus this 161 and then minus 161 here. We're going to combine like terms. We got x squared here. 4x plus 2x is 6x. 1 minus 161 is minus 160. And that equals 0. Two things I think of right off the bat that multiply to give me 160 is 16 and 10. And the difference between those is 6. So I want my 16 to be my bigger number, or my positive. I want my 10 to be my negative. And so when I solve that out, x equals negative 16 and x equals 10. Okay, so this has to be our answer. It said that it was positive. So that's what this x is represented by. And then this one, if we're doing x plus 1, that equals 11. Now if we did the square of 11, that's 121. 4 times 10 is 40. So 121 plus 40 is 160. So 10 and 11 are our answers. The length of a rectangle is 5 more than the width. The area is 500 square inches. Find the length and the width of the rectangle. The area of a rectangle is just length times width. So we said that the length is 5 more. So I assigned the w to be the variable that we're using. So we're going to call this w. W plus 5, that's length times width. And this equals that 500. So we're going to distribute this and say w squared plus 5w. This equals 500. We're going to subtract this 500. Move it to this side. There's no like terms to add it with. So we just get w squared plus 5w minus 500. This equals 0. And so we're looking for things that multiply to give us negative 500 and add to give us 5. So let's look at our calculator and see what we get on that. This y equals, put in that negative 500, divide it by x. And right there we can see that we got 20 and 25. So we're going to have 25 be our positive since this number was positive. And that 20 is going to be negative. Remember, they turn around and be the other way once we solve them. This is a negative 25 and this is a positive 20. Now we can't use the negative as a measurement. And so this width has to be 20 and our length is 5 more than that width. So our length is the 25. One number is 5 more than another. The difference between their squares is 125. What are the numbers? All right, so one number is 5 more than the other one, and it says the difference between their squares. Now, we have to be careful about which one we put first. We're gonna square both these, but we got to make sure that we put the bigger number. Remember, this one's 5 more than that one. That way when we subtract them, which is what difference means, we get this positive 125. If we're getting a negative, we'd have to make sure to do the opposite. So we're going to put this first. We're going to put this x plus 5. Remember, it's squared minus x squared, and this equals 125. So we're going to expand this out. So we get x squared plus 10x plus 25 minus x squared equals 125. Well, these cancel each other away. So we just have 10x plus 25 equals 125, and you're breathing a sigh of relief because this problem just got super simple. We're going to minus our 25 here, minus 25 here. We got 10x equals 100. I got my x. So now I'm going to divide both sides by 10, and so x equals 10. So that's what our first one is, just 10, and we plug in the 10 here. 10 plus 5 is 15. If we were seeing if this ends up being right, we're doing 15 squared minus 10 squared. Okay, if we do 15 squared, we should get to 25. We did 10 squared, that's 100, and the difference between that is 125, which is what we got. Our problem said it would be. A telephone pole has a wire attached to its top that is anchored to the ground. The distance from the bottom of the pole to the anchor point is 49 feet less than the height of the pole. If the wire is to be 7 feet longer than the height of the pole, what is the height of the pole? So since they declared that everything is in relationship to the height, we're going to use that as our variable, which is why we used our h right here. It said that the wire attached to the top of the pole to our anchor point is 7 feet longer. It said the distance from the bottom of the pole to that anchor point is 49 feet shorter. This telephone pole should stand and form a right angle with the ground, which means this is a right triangle. So that means we can use the Pythagorean theorem. Remember, this is our A, this is our B, this is our C. So A squared plus B squared should equal our C squared. So we're going to expand these things out. We get H squared plus H squared. This is negative 98H. I can't do that in my head. I'm going to have to look at the calculator and do 49 times 49. So we'll just do 49 squared. That gives us 2001. We'll expand this one out. We got H squared plus 14H plus 49. Ooh, kind of ran out of room on that one. We're going to cancel this away. Cancel this away. It's like we subtracted H squared on both of those. We're going to minus 14H and minus 49 here. That means we're minusing 14H here and minusing 49 here. So that leaves us with H squared, and then negative 98 minus 14, that should be 112H, and then 204 minus 49 is 2352, and this equals 0 now. Both those things canceled away. So let's look at our calculator and see what gives us 2352, but also adds together to give us that negative 112. We're going to need both these to be negatives. So they're going to combine to be that negative 112. I think we found it there. Yep, 28 plus 84, or negative 28 plus negative 84 would give us that negative 112. So that means that this H is 28 and this H is 84. Where you're thinking, oh, well, both those are positive. We can't cross anyone out like we have in these other ones. Well, if we plug this one in here, it works fine in these two things. But if we plug that 28 here, 28 minus 49 would give us a negative number. So we cannot use that one. So our height has to be this 84. One positive integer is 6 less than twice another. The sum of their squares is 680. Find the integers. All right, it said it was that our other integer was 6 less than twice our first or the other integer. It says the sum of their squares. So we're going to be squaring these things, and this means that we're adding them together. we're going to be saying x squared plus 2x minus 6 squared, that equals that 680. So I'm going to expand this one out. We get x squared, square that one, so we get 4x squared, times them together and then double it. That's going to give us negative 24x, and then negative 6 times negative 6 is positive 36. And that's equals 680. We're going to subtract the 680, bring it over to the other side, and then we're going to, that's going to make it go away on this side. We're going to combine like terms. We get 5x squared minus 24x, and then 36 minus 680 is negative 644, and this equals 0. I'm going to take this one and multiply it times this one. That's going to give me a negative 3,220. I'm going to write this up here as far as what we get. So let's use y equals and see what multiplies to give us negative 3,220, but has a difference of negative 24 in it. So let's do negative 3,220 divided by x. All right, so they're going to have a difference of 24. All right, we need these to be closer numbers, so let's start to bring these numbers down. I think that's going to be it. Remember, we keep these two the same, and so we're going to write 5x squared minus 70x plus 24x, and then we're going to have minus 644. And this equals 0. All right, we're going to do some factor by grouping. Since we have 4 terms now, we can divide out of 5x. That's our greatest common factor out of these 2 terms. That leaves us with x minus 14. This was supposed to be 46. This probably is supposed to be 46. 644 divided by 46. There we go. That's where our 14 is. So this is x minus 14 here. We factor out this equals 0. So we factor out our greatest common factor, which is x minus 14. And then what's left over are these 2 things. So we get 5x plus 46. This is going to be x equals 14. You might have to work this all the way out, but this one is pretty, well, let me work it out and then I'll explain what the fast way to do it on these. We're going to set this equal to 0. We're going to subtract 46, so that gives us 5x equals negative 46, and then divide both sides by 5, and x equals negative 46 over 5. So the fast way to do it is kind of thinking about it the way we did this one. Remember, this can become the opposite. So this positive 46 becomes a negative 46, and then we just end up dividing by what's in front of that variable, and that becomes our denominator on the bottom. I don't know where you can't see it, but you can see that that's where our numbers are represented. Instead of positive, we have a negative. I think it asks for an integer, so we can't use this one. So this has to be our x here. So this is going to be 14. Remember, we plug this 14 in, so 2 times 14 here minus 6. So 2 times 14 is 28, minus 6 is 22. Let's double check that. I always like to. If we did 14 squared plus 22 squared, that gives us that 680. So all that checks out. Incline mats or triangle mats are offered with different levels of incline to help gymnasts learn basic moves. As the name may suggest, 2 sides of the mat are right triangles. If the height of the mat is 28 inches shorter than the length of the mat, and the hypotenuse is 4 inches longer than the length of the mat, what is the length of the mat? So that's what they're saying. These actually are supposed to be the same, but we're just going to be looking at this triangle in particular. And it is a right triangle like the problem said. It said that the hypotenuse of this triangle is 4 inches longer and the height of it is 28 inches shorter. We can use the Pythagorean Theorem to figure this out. This is our A, that's our B, this is our C. So we're doing L squared plus L minus 28 squared equals L plus 4 squared. Well, we're going to expand these two out. We should get L squared plus L squared minus 56L. And let's do 28 squared. That gives us 784. We can finish this off. We get L squared plus 8L plus 16. We can minus our L squareds. That's going to cancel these two away. Let's minus 8L and minus 8L here. We're going to minus 16 and minus 16 here. That leaves us with L squared. This would minus 64L. And then we're going to subtract there. And that's just going to be minus 16. So we get plus 768 equals 0. Now we're going to get two negatives. We combine together to give us this. And so let's plug this into our y equals. Let's clear this and we'll put in our 768 divided by that x. And so these should combine to be that. I think that's going to be it. So 48 plus 16 is 64. So we got 48 here, 16 here. That means our length could be 16, or it could be 48, except when we plug this thing in here, that would give us a negative number. So we can't use our 16, have to use the 48. One positive number is 3 more than twice another. Their product is 14. Well, 3 more than twice another actually looks like this expression. 3 more means that we're adding to it. Twice means that we're multiplying it. So this is good here. We also see that number here. So it's either this first or the second one. Now, if it says sum, we're going to be doing this one. If we're doing product, we're doing this one. And it says product. So this is certainly our equation we're using. So the first thing we're going to do is distribute this x. X times 2x is 2x squared. X times 3 is 3x. And that still equals 14. We're going to subtract the 14. Bring it over to the other side. So we get 2x squared plus 3x minus 14 equals 0 now. Now we're going to have to multiply this 2 times the 14. That gives us 28. I'll write it up here. If we go down our list, we're going to find that 4 and 7 have a difference of 3 between them. And we want this 4 to be our negative since we got a positive 3. Our positive is always bigger if that one is a positive. So we're going to have 2x squared minus 4x plus 7x minus 14 equals 0. All I did was just use that with the x. If we combine these back again, we recreate that. These two numbers stayed the same. Right? So we're going to do factor by grouping. And looking for the greatest common factor, we're going to find that this one is 2x. And we should have x minus 2 left over. Both of these we can divide out of 7. And so x minus 2 should be what's left behind. So then this becomes our greatest common factor. This is left behind on the outside of the parentheses, 2x plus 7. And that equals 0. If we solve these out, This is the only one that really gives us an integer, so x equals 2. Remember the fast way of doing this one, to get the opposite of this, so negative 7 over 2 would be this one. So if we plug in the 2 here, that's our answer here. This would be 2 times 2 plus 3. So 2 times 2 is 4 plus 3 is 7. And you can see that 2 times 7 is 14. So this thing checks out. The difference between two positive integers is 6. If the smaller is added to the square of the larger, the sum is 126. Anytime they use difference, it typically means subtraction. But in this case, it's just saying that one is 6 more than the other one. So we could also add that as well. And that's what they did in this. They added 6. And you can see all of them have this in it. So all possibilities are open at this point. So we're going to go on to our next sentence. It says, if the smaller is added to the square of the larger. So we're going to be adding between this. This has multiplying. We're also going to have a square in it. So it's only going to be these two. But since that one's multiplying, it has to be this one. So this is going to be our answer. So we're going to expand this parentheses out. We get x plus x squared plus 12x plus 36. This equals 126. We're going to subtract this 126. At the same time, we're going to be adding our like terms that we have here and here. That gives us 13x. We got x squared plus 13x minus 90. And now this equals 0. So if we're listing off our things that give us negative 90, we can go down the list. Remember, our positive is going to be the bigger number. So we're going to have negative 1 and 90, negative 2 and 45, negative 3 and 30. 4 doesn't work. We got negative 5 and 18, and that's where we found our things we need. So this is going to be x minus 5 and x plus 8, 0. Okay, so x equals 5, and then x equals negative 18. You could plug these in and figure it out. I think it might have said positive. We're just going to use positive. So this x is going to be 5. Plug in our 5 here. 5 plus 6 is 11. And 11 squared is 121, plus 5 is 126. It does say positive integers, so we make sure to use that 5 and 11. Bill uses mirrors to augment the laser experience at a laser show. At one show, he places 3 mirrors, A, B, C, in a right triangular form. If the distance between A and B is 12 more than the distance between A and C, and the distance between B and C is 12 less than the distance between A and C, what is the distance between mirror A and mirror C? So here's our mirrors. This is mirror A that we have here. It's shining this laser over here to mirror B, and then it's bouncing off to mirror C here, and then keeps going in this right triangular pattern. It compared things to A and C, which we assigned to be our variable. It said the distance between C and B is 12 less, and then it said the distance between A and B is 12 more. Now, we're going to use the Pythagorean Theorem to figure this thing out. So, this is our A, this is our B, this is our C. So we're going to have x squared plus x minus 12 squared plus, equals our x plus 12 squared. Okay, so we're going to expand these things out. We get x squared plus x squared minus 24x plus 144. That equals x squared plus 24x. Let me make that prettier. Ugh. I don't think that I made it any prettier. All right. One quick thing we can do, we can minus x squared here. That's going to cancel away on both sides. We can minus 144 on both sides. That cancels those two away. So now we're just subtracting 24x on that side, subtracting 24x on this side. Cancels away on that side. So hang on. I'm not smart. Cross this out. Let's ignore that. This would be x squared minus 48x equals 0. And so if we take out the greatest common factor, this would be x minus 48 equals 0. So our x would either have to equal 0 or 48. If we were saying that x equals 0, then there wouldn't be any measurement between this. In fact, this would collapse down all the way next to C, and there wouldn't be any measurement between it. So that laser would be shooting just back and forth. So we wouldn't even have a triangle anymore. So we can't use this 0, but I just got ahead of myself. So our answer has to be 48.